Hi everybody, today we will be discussing how to determine special right triangles. Two triangles that we will be discussing are the 30-60-90 right triangle and the 45-45-90 right triangle. But first let's talk about the 30-60-90. The theorem for the 30-60-90 right triangle states that across from your 30-degree angle, your side length will be x. Across from your 60-degree angle, the side length will be x radical 3. And across from your 90-degree angle will be 2x. So in order to prove it, we will use the Pythagorean theorem. So we're going to substitute in our a value as x, b value as x radical 3, and our c value as 2x. This then simplifies to x squared plus x squared radical 9 is equal to 4x squared. After further simplifying, we will get 4x squared is equal to 4x squared. This proves the 30-60-90 right triangle due to the fact that there are infinitely many solutions for x. So whatever value is given to you for your x value, all you do is substitute into your triangle to get x, x radical 3, and 2x. This will be used later on in an example in the video. Next, let's look at the 45-45-90 right triangle. Due to the fact that there are two equal angles in this triangle, this makes this triangle an isosceles right triangle. Therefore, across from each 45-degree angle, the side lengths will be the same. And across from your 90-degree angle, the side length will be x radical 2. Now to prove this theorem, we will again use the Pythagorean theorem and substitute in our values. So here, a and b are both equal to x because, again, the legs of the triangle are equal. And our c value, or our hypotenuse, is x radical 2. After simplifying, we get 2x squared is equal to x squared radical 4, which simplifies to 2x squared is equal to 2x squared. Again, since the left side of the equation is equal to the right side of the equation, we know that whatever our x value is, we can substitute in for a 45-45-90 right triangle to get side lengths of x, x, and x radical 2. Let's try some examples. Compute the value for both y and z. So if you look at this triangle, you can clearly see that there is a 90-degree angle as well as a 30-degree angle, showing that this is a 30-60-90 right angle. Next, since this is a 30-60-90 right triangle, we are going to use the theorem for x, x radical 3, and 2x. Across from our 90-degree angle, we clearly see that we know our side length is 12 radical 3. So first, let's solve for x. Here we have 12 radical 3 is equal to 2x. We're going to divide both sides by the coefficient of 2, and we will get 6 radical 3 is equal to x. We also know that across from our 30-degree angle is our y, but in our theorem, it is represented as x. So in order to solve for y, we can simply state that 6 radical 3 is equal to our x, which happens to also be equal to our y value. So the first value that we were missing was y, and that is equal to 6 radical 3. Now let's solve for z. Z is across from your 60-degree angle. So you know that when we're solving it, x radical 3 is equal to z. Since we know that x is equal to 6 radical 3, we're simply going to substitute to get 6 radical 9 is equal to z, which also simplifies to 6 times 3, which is indeed equal to 18. So the third length of our triangle is 18. So the triple here would be 6 radical 3, 12 radical 3, and 18. Here you are given the 45-45-90 right triangle. Across from your 45-degree angles is side length x, and across from your 90 is 3 radical 2. If we look at the theorem, we will clearly see that your hypotenuse is equal to 3 radical 2. So in order to solve for x, all we need to do is set them equal to each other. In order to solve for x, we will divide both sides by the square root of 2 in order to get x is equal to 3. Therefore, we know the side lengths across from the 45-degree angle is equal to 3. Thank you for watching, and I hope this clarifies this special right triangle theorems.